Okay, welcome back. As you can see, I am in the gym. It's me alone. Real life example. Okay, we're going to take a look at something simple. So, here behind me, when I stand here, is the basketball hoop. Now, the question is, in terms of the basketball hoop, if I'm standing right under the basketball hoop, for those of you that know basketball, this net above my head, which I'm way too short to jump to, is 10 feet in height. However, if I'm standing directly under the net, in front of me is the 3-point line. So the question, if I could ask, is how far is the 3-point line from directly underneath the basketball hoop if I was looking up at an angle of, say, 35 degrees? So, knowing what the problem looks like, let's take a look how to solve it. So we're going to walk over to my trusty whiteboard. It's because I can't move it to the middle of the field or the court. So I've tried to do a drawing, replicating what we're going to work with. We have our basketball hoop. We know it's 10 feet. Out here is the 3-point line. And now we're kind of in center view. So looking at our ratios, well, which ratio can we use? Well, we know the angle. We know the side opposite, that's the height. We need to know where this 3-point line actually is. Well, this side, according to this angle, is adjacent. Well, let's look at our ratios. Our ratio states that the adjacent and opposite is our tangent function. So, TOA is the tangent of an angle divided, which is equal to the opposite divided by the adjacent. Well, we know the tangent has to be about 35 degrees, is equal to 10 feet over this ADJ. If we recall from previous videos, these two can switch spots to find the math. Rewritten, that says that the ADJ, or adjacent side, is 10 divided by the tangent of 35. If I punch that into my calculator, so what I would do is go 10, hit the divide button, then tan, a bracket will show up, punch in 35, close the bracket, hit equal, and I should, according to the proper math, get 14 feet. So that would mean, essentially, that if I am here shooting the ball from the 3-point line, I'm not going to because I ain't going to get it right. But if I'm standing here and I shoot it, I'm shooting the ball roughly 14 feet in the air if I shot in a straight line going up. No, straight line going on the ground. But we know the hypotenuse is longer, so you'd actually be throwing the ball at a different. I'll take you back and place it there before we close up the video, just so we remember the math. All right. We got our angle, height. We now know that the 3-point line is roughly 14 feet away. How far you would actually throw the ball is the hypotenuse. Now, I could ask that question, and you would just use a different formula. If I just wanted to know how far you were throwing the ball from here to here, we wouldn't use tangent. You'd have the opposite in hypotenuse, and that would be that equation. Okay? Hopefully that kind of is an example. I'll add a whole bunch more to make this a little clearer for you guys to do.